Hi guys, good morning to all of you. Hello. Yeah, this is Nageswar Rao, your faculty. Yes, trainer for Linux. Yes.
Good morning.
Do you hear me? Yeah. Do you hear me, everyone?
Okay.
Hello.
Hi.
Yeah. Do you? Yeah. Okay. Okay. Yeah. Thank you. So let us start our session. Yes. So yesterday just introduction given. Nothing we discussed yesterday about about myself. Next about course. Yes, course contents discussed. Next, what is the prerequisite for whom? All that just that what you discussed. Today we'll enter into actual topic. Okay. Today enter into a topic here. Okay, right? Yes. Yes, to learn a Linux base, nothing required. I'm not expecting anything from you. Okay. No expectations. Yes, non-IT background guy also can understand this. Anyone can understand here. Yes, you can start your career with Linux base. Okay. Yes, it's very beginning course. Okay, so no expectations from you, right? Okay, yes. So let us start from very beginning. Yes, computer ware. Yes, ware. Computer ware. In computer ware, there are two categories. First one, hardware. Next, second one, software. Right? Hardware and software. First one, hardware. Next is software. What is hardware? What is software? Let us see this. What is the hardware? Yes, hardware. Yes, these are physical components of a computer. Yes, hardware. These are physical components. Okay, these are physical components. Hardware. Yes, these are physical components. These are physical, yes, components. Physical components of a computer. Yes, physical components of a computer. Just physical components. Okay. Yes, hardware. These are physical components of a computer. Okay. For example, yes, device drivers. Yes, sorry. For example, physical components like a keyboard, keyboard. Yes, keyboard. Yes, next mouse. Okay, next mouse. Next hard disk. Okay, next motherboard. Okay, RAM memory. Yes, all this comes under physical components, right? Keyboard. Yes, your keyboard, mouse, hard disk, motherboard, RAM. Yes, all the things comes under hardware components. Yes, we can touch all these parts. Yes, we can touch all the parts, right? So this is hardware, but we are software engineers, right? We are software. So let us move to software. What is software? Okay. Yes. What is software? Let us see about software. Okay. Yes, 1 minute, guys. Yes, today actually I'm not feeling well. I'll explain very slowly. Okay, not well. Yes, I'll explain slowly. Yes, sorry. Yes, software. Yes, what is software? In software, yes, everything program. In software, everything is programmed here. All are programs. Everything is programmed. Yes, in software, everything is programmed. Okay, it's a collection of programs. It's a collection. It's a collection of programs. It's a collection of programs. Software, in software everything is program. It's a collection of programs. Okay, yes, like collection of programs like C, C++. Yes, maybe Java. Okay, maybe Python program. Yes, all is Python, all the programs. Just it's a collection of programs. Software, it's a collection of programs. Everything is program. In software, everything is program. It's a collection of programs like C, C++, Java, Python, something like this. Okay. Yes, in software, basically two categories. In software, basically two categories. Yes, first one, system software. First one, yes, system software. Yes, next one, application software. Second one, application software. Second one, application software. System software. Next, application software. Yes, what is system software? What is application software? Let us see one by one here. Yes, system software. What is a system software? Let us see about system software. System software. Yes, what is system software? Okay, system software. This is to interact with hardware components. It will interact with hardware components. System software. Yes, it interacts. Yes, system software. Yes, it interacts. Yes, it interacts with. Yes, it interacts with. Yes, hardware components. Interacts with hardware components. Interacting with the hardware components. Okay, right? System software. System software. Next, application software. System software interacts with hardware components. Hardware components. Yes, examples. Yes, like device drivers, device drivers, and operating systems. And operating systems. Device drivers and operating systems comes in this category here. Okay. Yes, interacts with hardware components. Example, device drivers and operating systems comes in this category. Okay, right? Yes, device driver. Yes, what's it? Yes, so device driver operating systems we'll see next year. Before that, little bit about application software. Yes, system software. This one interacts with hardware components. Example, device drivers and operating systems. Okay, right? Yes, next application software. What is application software? Let us see about application software. What is an application software? Okay, application software. This is yes for the purpose of yes application software. Yes, this is for the purpose of application development. For the yes purpose of application. For the purpose of application development. For the purpose of application development. This is for the purpose of application development. Okay, application software for the purpose of application development. Yes, application app. Yes, application means yes like yes applications. Yes, daily. Yes, every day we are working with many kind of applications, different applications. Okay, yes, like Facebook, it's an application, right? Facebook, it's an application. Okay, yes, next Gmail, it's an application. Google search engine, it's an application, right? Google, it's an application. Yes, Google. Yes, Google, it's an application. Okay, yes, next Durga website is an application, right? Durga website is an application. All the applications, right? How to develop these applications here? To develop these applications, some software is required. Those are called application softwares. Application software for the purpose of application development. For the purpose of application development. Yes, applications like Facebook, next maybe Gmail, yes, Google, maybe Durga website, maybe on Amazon, that online shopping, maybe Flipkart, yes, banking applications, all the applications, right? To develop these applications, we need some software. That is called as application softwares. Yes, application software, best example, Java. Yes, application software, best example is Java. Yes, in market, most of the applications developing Java here. 80% of applications, 80% of total application software field developed in Java. Okay, Java is the mostly used application software. Okay, Java. Yes, next C language, next C++, Python. Yes, all the application softwares except OS, except operating system, everything comes under application software. Except OS, all are application softwares. Right? Okay. Application software for the purpose of application development. As application softwares examples, Java, C, C++, Python, .NET, SAP, except yes, except this OS, everything. Yes, even database also comes under yes, Oracle database. This also comes under application softwares. Right? Okay. Yes, right? So about application software. Actually, our part is system software. Linux comes under system software. Our part is system software. So let us go to system software here. A system software, this one interacts with hardware components. System software interacting with hardware components. Yes, for these examples, device drivers and operating systems. Device drivers and operating systems. Yes, let us say about device drivers. Yes, what is device driver here? Device driver. See here, what is exact device driver? See here, to run any device, some driver requires. To run any device, driver requires. Without driver, devices will not work. To run any device, driver requires. So without driver, devices will not work here. Compulsory driver requires. For example, printer. Suppose your system connected to printer. To run that printer, driver requires. Otherwise, it won't work. Okay, suppose yes, your system connected to some yes scanner. For this driver requires scanner, printer, maybe fax machine. Suppose your system your computer connected to TV. For this also drivers required. Okay, so exactly what is this driver here? Yeah, this is one kind of program. Just all drivers are programs. Yes, almost all drivers were developed in C language. Almost all drivers were developed in C language. Means they are the programs. Simply these are the programs. So what is device driver? Yes, it's a program. Device driver is a program. Yes, it's a program. Yes, to communicate. It's a program to communicate with the hardware components. It's a program to communicate with the hardware components. Right? Okay. These all are just basics in software field. Just before going to Linux base, just basics. These all these things here. Yes, it's a program to communicate with the hardware components. Just it's a program to communicate with the hardware components. Yeah. Okay. Yes. Here, every device driver requires. Without driver, devices will not work. Okay, devices, yes, devices will not work. To work without driver, devices will not work. Devices will not work without driver here. So without driver. So without driver, driver required compulsory here. So without devices will not work without driver, right? So devices will not work without driver. Correct? Okay. Yes. Here, these drivers, who will supply these drivers here? That hardware manufacturer. Yes, who is manufacturing that hardware? They will supply that hardware vendors who are selling hardware in the market. They will provide this. Okay. So device drivers, device drivers, the device drivers supplied by the hardware vendors. Device drivers. Okay, these all these things supplied. Okay, supplied by the hardware vendors. Hardware vendors. So hardware vendors. Okay, they will supply this kit. Hardware vendors means who are selling hardware, sellers. Okay, who are selling hardware kit, they will provide it. Okay, yes. So what is device driver? It's a program to communicate with hardware components. Okay, so devices will not work. Devices will not work without drivers, without driver kit. So device drivers are supplied by hardware vendors. Okay, device drivers. For example, yes, example printer driver. Yes, printer driver. Okay, yes, scanner. Yes, maybe scan display drivers like TV, display drivers. Right? Okay. So these are about device driver. All right. Okay. Yes. Let me open document. Yes, here about notes and all this. It's not necessary. I have prepared everything. Yes. 1 second. Let me open Linux document. Yeah, document very clearly prepared. Yes. See this in document. Yes, from the beginning, basics of software. So what is software? It's a collection of programs such as C, C++, Java, and SQL other programs, right? Software basically two categories. System software. Yes, application software. In software, system software, next application software. Yes, application software for the purpose of application development. For example, C, C++, Java, .NET, and ERP other package here. All the application softwares. Next, system software. This one interacts with hardware components. System software interacts with hardware components. Example, device drivers and operating systems. Right? Okay. Device driver. See this. Yes, these are the programs to communicate with hardware components. Every device has its own drivers here. Okay. Device drivers are supplied by hardware vendors. Right? Okay. It's there in document very clearly. So don't worry about notes. It's not necessary to write the notes here. Yes, not necessary. Okay, no need of writing notes here. It's here in document. Okay. Yes, every topic very clearly prepared document.
Is it a demo class or is it a real class?
Yeah, yes, who is talking?
This is Narendra.
Yeah, yeah, it's a class actually here, not demo class.
I'm not getting a class link. I'm getting a training type of link, register every day. So I don't know. Maybe you can send email to
No,
Durga.
no.
Can you send me the
Yeah,
real link?
yeah, it's a real class actually, not demo class actually here. Just introduction. First 10 minutes just introduction. After that, I will be entering Linux base, Linux
No,
features
no, I'm
next
fine.
topic.
I'm fine. The link, I don't get the link. So
It's
if
not
you
a
guys can
demo class. It's not demo class. It's the actual topic actually. Okay.
good. Continue,
Yes,
continue.
not a demo. Yes, here it will be continued. Yes, today just this topic basics. Today topic basics will be finishing. After finishing basics, I will be entering into Linux base. It's not a demo. It will be this class will not be repeating tomorrow. Okay, it's a continuation. All right. Yes, demo means actually here first two classes they will allow two of free of cost. That's it. Here. That's a
So
demo.
when can
Nothing.
we get
Okay.
the recording sessions?
Hello, Nageswar
Hello.
Rao. This is
Yeah.
Ravi.
Yeah. Yeah. Tell me. Yeah. Tell me. Hello. Yeah. Ravi. Hello.
Hello.
Yeah. Tell me,
Yes,
Ravi.
hi, Nageswar. Actually, this training is for only beginners and beginners to expert.
No, this is for starting from beginner to high end. I'm taking high end. Yeah, the thing is here.
Okay.
Yes, from the beginning. Yes, from the very scratch, I'll start
High
here.
end, and in the sense we can you can go into cover all the RSC.
No, this is not for beginners, for expert here. I will
Hello.
start from the beginning. I will
You can
start from
go to write the exam, the RSC, RHSA.
yeah. For them only here. Yes, I'm starting with basics here. Basics
Certifications.
to high end. Who are wanted right? RC for this very helpful this course. Okay, 90% you can score in RC with this course. Okay, Red Hat. Yes, that enterprise. Yes, certified engineer here. Red Hat certified engineer. 100% you can score it. Okay. Yes, here I'm starting with basics. Just I'm starting with basics, then I'm taking to high end. Okay. Yes, including admin. Yes, your our course yesterday explained about all the course contents. So first is starting with basics here. First is starting with basics.
Okay.
First is basics. After starting with basics here, next user level comments. So user level comments, taking to user level comments. After finishing user level comments here, next is shell scripting. Yes, is shell scripting. Yes, shell scripting. Yes, after finishing shell scripting, next admin commands. Yes, admin commands. Okay, admin commands. Okay, yes, totally it's a 30 days course here. It's 30 days course here. Yes, first 10 days that user level commands finishing here. Next 10 days shell scripting. Next 10 days admin commands. After finishing that, there will be a project here. Okay, yes, you can write RSC this very clearly here. Ready Hat, that certified engineer here. Okay, 100% you can write it, 100% you can score it. That is my yes assurance. Okay, yes, starting with the low end, starting with very basics, and then I will take to high end here. Okay, this is basics here. So next to take into this yes, features, Linux features here. After that, Linux architecture. After finishing Linux architecture, next what is interpreter and compare these basics here. Yes, after Linux distributions here. Next, after that, yes, Linux file system going to discuss. Yes, how this Linux file system, all this Linux file system, complete file system. Linux file system going to discuss here. After that, all the user level commands. Yes, all this. It's a more 100-page document here. 100-page document here. Yes, every comment I'm explaining very clearly. Whatever Linux is here, everything starting with basics, then taking to high end, including administration. Okay, in-depth coverage of administration, in-depth coverage of shell scripting here. Yes, you can write. Yes, that certification course very easily you can write it. Okay, it's a 100% assistance. Yes, you don't worry because here some beginners they will be starting with Linux base, right? Okay. Yes, for that purpose, I'm taking from the beginning here. Very scratch, starting from very scratch, then taking to high end. Next, any other doubts? Hello? Hello.
Hello.
Yeah. Yeah. After this course, you can apply for 4 to 5 years of experience, not 3 years. 4 to 5 years. That is guarantee here. 4 to 5 years of experience. Okay. See, I'm very expert in Linux administration area because I worked on big data, Hadoop, and Linux admin area. Yes, I worked in data center for yes, 2 years, more than 2 years. I worked in ESA. Okay. Next, since 97, I'm working on Linux area, embedded C projects, Hadoop projects, and Java projects. Okay, most of the complete career Linux phase, 20 years of experience in Linux phase. Okay, you can claim 3 to 5 years of experience in Linux phase. That is assurance from me. Okay, yes, you can, even I can give the resume for this 3 to 5 years of experience resume. I can give you, and you can put up to this much here. That is from my side. Okay, right? Yeah, so definitely I'll give the resume. 4 to 5 years of experience resume I can give it. Okay, that much of topics we going to cover. Very in depth. Yes, I'm covering here. Yes, you will see going forward. Yes, it's a beginning, first day. Because of first day, yes, starting from the basic. Okay, suppose if you enter directly here, may not be understanding. So before going to Linux base, we need some basics. Okay, so need some basics here. For that reason, I'm explaining basics. After that, then I will take to I end. Right? Okay. Yes, fine. Yes. So this is drivers here. Next, our topic is operating system. Yes, operating system. Yes, operating system, right? Our topic is operating system. Okay. Yes. Next, anything else? Yes, Sashi. Any doubts? Narendra? Narendra. Zakir, Narendra, Sashi, Ravi. Next, two more guys. Yeah. Okay. Let us continue. Yes, our part is OS. What is operating system? Let us see about this. Okay. Yes, what is OS? Here, some question for you. Yes, today new guys. Yes, some question for you. Yes, can we run any program without OS? Yes, new guys. Yes, can we run any program without OS? Say yes or no. Yes, can we run any program without OS? Question is, can we run any program without OS? Say yes or no. Right? Yes, no one answering. Can we run any program without OS?
No.
No, we can't run. Compulsory OS required. Compulsory OS required. Without OS, we can't run any program here. Right? Okay. Yes. Let me explain that here. 1 second. See, suppose learning something, maybe learning Java, learning C language, learning something here. 1 second. Maybe Java learning, Hadoop learning, something learning. For the purpose of learning, you might have purchased your laptop. After purchasing laptop, what is next step? We should install OS. So next is we should install OS. See here, first your OS, right? So hardware, yes, hardware. Okay, first hardware, yes, on top of hardware, next OS, right? Yes, operating system, right? Yes, after this, on top of that, yes, next installing C or Java, something like this. These all are application softwares. On top of OS, then they say application software. Application software like C, yes, maybe C++, yes, maybe Java. Okay, C language, C++, maybe Java, maybe Python, yes, maybe Hadoop, yes, all these softwares, right? Yes, maybe Oracle software, Oracle database, yes, maybe including MS Office also, MS Office, like this, right? Okay, yes, on top of OS, All are these things running, right? Without OS, we can't run these programs. Without this, yes, without. Okay. So without operating system. Okay. So without operating system here, we can't run any programs, right? Yes, to run all the programs, OS required. So on top of OS, all the programs running, right? Maybe C programs, C++, Java, Python, something like this. All the programs running on top of OS. All the programs running on top of OS, right? So on top of OS, all the programs running. So somewhat like a platform, right? So OS is like a platform. So what is OS? It's a platform. OS is a platform where we can run all the application softwares. It's a platform. Okay. So what is OS here? OS, yes, first point. Yes, it is a platform. It is a platform. Yes, where we can run, yes, where we can run all the application softwares, right? Just like a platform. So this is like a platform. Okay. Yes, where we can run all the application softwares. OS is a platform. Yes, it's acting like a platform here. It's a platform where we can run all the application softwares. Okay, right? Yes, next. Not only platform here. Suppose for example here, C program, running here. So C program generating some output here. Suppose Java program running here, maybe generating some output. Suppose Python program running here, generating some output, right? Suppose C program generating output here. C program generating output here. So first output, C program output goes to OS. C program output goes to OS here. Okay, from there, yes, next. Yes, from that it goes to output device. So first C program output goes to OS to output device, right? Okay. Suppose reading from the keyboard. Suppose C program reading data from the keyboard. So first keyboard data goes to OS, right? Keyboard data goes to OS. Yes, then OS to C program, right? That's it here. Okay. So here vice versa like this, input output here. So here C program or Java program, Python program, something like this. All the programs. So all the programs, first of all, output goes to OS to output device. Suppose reading from the keyboard. So first the keyboard data goes to OS to then your C program, right? So between these application software, yes, maybe C or Java, Python, yes, all the application software, right? All are application softwares. Okay. So between application software and hardware, there is a OS. It's like a mediator, between, like a mediator. Exactly, terminology is interface. We can say it's an interface. Okay. So OS is acting as an interface between application software and hardware components. Okay, application software and hardware components. See here, yes, application software to hardware. There is no direct communication. No direct communication here. No direct communication between the sticker. Okay, there is no direct communication here. So first, yes, application software. Yes, data to OS to, yes, hardware. Yes, similarly vice versa here. Hardware to OS to application software here. So between application software and, yes, hardware, there is a OS. Between application software and hardware, there is a OS. So like interface, it's an interface. Simply you can say it's an interface between application software and hardware components. Okay. So next is second one. Yes, it's an interface. It's an interface. Yes, it's an interface. Yes, it's an interface. Yes, between, yes, it's an interface between, yes, application software and hardware components, application software and hardware components, right? Okay, just it's an interface. Okay. So it's a platform where we can run all the application softwares. Next, it's an interface between application software and hardware components, right? Okay. Yes, here to communicate, yes, to communicate between, yes, to communicate between hardware and application software, every OS has its own library here. Input output library. There is a library here. Input output library here. So using input output library, it can communicate between application software and hardware components, right? Okay. So every OS means, yes, maybe Linux OS, Windows OS, or Unix OS, all the operations. Every OS, yes, contains. Every OS contains. Yes, every OS, yes, contains. Yes, contains its own library here. Its own library. Every OS is having its own library here. Okay. Every OS having its own library to communicate. Okay, to communicate between, yes, to communicate, yes, between application software, to communicate between application software and hardware components, to communicate, yes, to communicate between, yes, application software and hardware components, right? Okay, yes. So this is just a basic idea about OS here. What is OS? OS is a platform. OS is a platform where we can run all the application softwares. Next, it is an interface between application software and hardware components. Next, every OS has its own library to perform I/O operations between application software and hardware components. Yes, same topic is prepared in document here. Yes, you can see the document here. Yes, in document. See, what is OS? It's a platform where we can run all the application softwares. Next, it's an interface. It's an interface between, yes, hardware and application softwares. Okay, next, every OS has its own library to communicate between application software and hardware components. See, this OS architecture, hardware on top of this OS, next application software, right? So this is just introduction to OS, just introduction. Okay, next. See, now operating systems basically two categories. Okay, so there are two categories basically here. Two categories. Basically, there are two categories here. Two categories. So first one, yes, character user interface or command line CLI, command line interface. Okay, character, yes, character user interface, character user interface or command line. Anyone you can say command line. Yes, command line interface, command line interface. Okay, command line interface, character user interface or command line here. Second one, GA, second one, GA, graphical user interface, graphical, yes, graphical, yes, graphical user interface, graphical user interface, right? Okay, yes, CA. See, this is character interface, right? See, command prompt, yes, Windows command prompt, Windows command prompt. See here, start button here, command prompt, right? Here, command prompt. Yes, it's a character interface. CLS clearing screen here. D drive, that will take to D drive here. Okay, right? Yes, DER some output like this. CLS clearing screen here. DER some output. Yes, here DAR means directory, right? These all are directories. All the directories. All the directories here. For example, test is a directory. Test is a directory here. CD test. CD test. Change right. CLS clearing screen here. Not DER some output like this. In this T1, DAR means directory. What is directory here? Directory is similar to folder. Directory folder both are same. Directory is similar to folder. See T1, T2 directories, right? Yes, next X1, X2, X3, X4, there are directories here. Okay. D drive test, D drive test, right? D drive test here. D drive test. Yes, in test, all these here, all these, they are directories. Okay. Yes, let us go to GA here. In GA, D drive test, they say test here. Yes, test folder series X1, X2, X3, X4, they are folders, right? All the folders here. Yes, the same here. It says same directories, right? Yes, in directory similar to folder, directory similar to folder. Okay. Yes, in character interface calling as directory. Yes, in graph interface calling as folder. Only that interface difference here. In character interface, it's a directory. In graphical interface, a folder. That's the difference. Both are same here. Right? Okay. CLS clear the screen. Next, DAR, some output is playing here. Okay. Yes, these are directories, right? DAR means directory here. Okay. Next, one more thing here. Yes, command DAR. What is this DAR? Any idea? What is this DAR? This DR stands for what? Any idea? It's a command DR. The DR stands for what?
Disk information
Directory.
record, something like this, sir.
Yeah, yeah, disk information report. Okay, it's a disk information report. Yes, DR stands for disk information report. Okay, here this one shows information about disk here. The data inside of the disk here. So about D drive. D drive test. Test is a folder. Inside of folder contents, like folder contents means disk contents. Okay, so DAR, this stands for disk information reports. Okay, DER means, yes, DER, yes, this stands for disk information, yes, disk information reports. This stands for disk information report here. So this is providing information about the disk here, information about disk. Okay, information about disk, right? Okay, yes, so this is DER. See that all that information showing, right? All that information. Okay, fine. Yes, so this is character user interface, right? Okay, yes, this is MS DOS. Yes, working with MS DOS very simple. Yes, once you have the Linux experience, you can work with the MS DOS. Same commands. Suppose creation of directory, MD, creating directory here. Suppose some x1, yes, already there here. Suppose x11, yes, created here. Yes, suppose x22, yes, creation of directories, cdx, change of directory here. Okay, x don't have, mdx here, make directory of x, okay, cdx, change of x here, dr, that content here. Okay, cls, clearing screen here. Yeah, these commands are similar to Linux commands. If you have the Linux, you can work with the DOS here. It's MS DOS, Microsoft Disk Operating System. Okay, so once you get the Linux experience, you can work with this here. It's not an issue, right? Okay, so this is character user interface. Character user interface, right? Okay, next, this is GA, graphical user interface. Windows is GA, right? Okay, so here operating systems basically two categories: character user interface or command line interface. Okay, right? Next, GA, graphical user interface, right? In both cases, yes, in both cases yes, in both cases character interface and graphical. In both cases character interface and graphical. Yes, in both cases there is a single user OS, single user OS, next multi user OS, single user OS and multi user OS. Okay, yes, again two categories: character interface and graphical interface. Two categories like single user operating systems and multi user operating systems. Okay, see here, yes, character interface and graphical user interface. Character interface and graphical interface, in both cases the single user, multi user, single user and multi user. What is single user OS, what is multi user OS? See, single user applications were outdated, no one using. Nowadays everything is multi user OS. All are multi user applications like UNIX multi user, Linux multi user, Windows 10 multi user, Windows 8 multi user, 7, all the multi user applications. Okay, yes, here single user not using, these were outdated. Yes, we'll discuss what is the difference here. Yes, first about single user OS. What is single user OS? Let us see about it. Single user OS. Yes, about single user OS. What is single user OS? Okay, single user OS. Single user, yes, only one user, only one user can use, only one user can use system resources. Only one user can use system resources. Yes, system resources, that could be file or some application running on system, file or some app. Okay, file or some app or maybe database data. Yes, only one user can use that. Standalone system, this is called a standalone system here. So this is called a yes, standalone operating system. Okay, only one user, single user operating system, only one user can use system resources, maybe files, maybe application, yes, maybe data here. Only one user can use that. No sharing, it does not support sharing here. Reason, yes, no networking concept here. Okay, it does not support networking here. Okay, so this is called a standalone system here, standalone wise. Okay, it does not support, yes, it does not support networking here. Okay, yes, only one user, this is called a standalone wise here. Next, it does not support, it does not support networking. Yes, it does not support networking, it does not support networking, right? Okay, since not supporting networking here, there is no chance of sharing resources. Data cannot be shared here. Data cannot be shared here. Data cannot be shared here. Data cannot be shared. Okay, data cannot be shared here. Okay, we can't share the data here, so as it is not supporting networking here. Okay, as it is not supporting networking here, right? As it's not supporting networking. Okay, not supporting network, right? Okay, it's a standard system here. Yes, single user OS, only one user can use system resources. That resource could be file or application data. Only one user can use that data. No sharing resources. No sharing resources here. Okay. Yes, here is a standalone OS. This is called as standalone OS. Okay. It does not support networking here. It does not support networking here. Okay. Yes, it's older, very olden days. Okay. Yes. Yes, data cannot be shared. Yes, data cannot be shared. Data cannot be shared as it is not supporting networking here. Right? Okay. So this is about single user OS. Right? Okay. Yes. Second one, multi-user OS. What is multi-user OS? Single user OS character interface best example is DOS. MS DOS. MS DOS is the best example of this. Yes, about MS DOS we'll discuss next. That history we'll discuss. Multi-user OS. Yes, what is multi-user OS here? Multi-user means more than one. More than one. Yes, more than one. More than one. Yes, it could be. Yes, more than one. Yes, it could be 2 years or 3 years or tens of users. Okay, or hundreds of users or thousands of users. Thousands of users can share the data here. Can share the data. Or can share the data. Can share the data. Okay, data sharing here. Yes, more than one. Yes, more than one user here. More than one user. Yes, more than one user. Yes, it could be yes 2 users or three. Yes, tens of users, hundreds of thousands of users can share the data here. Okay, right? Yes, it supports networking here. It supports networking. It supports networking. It supports networking. Okay, this is called a server OS. Yes, it is a server OS. It's a server. Server means serving resources. It's a server OS. So this is called a server OS. It's a server OS. It supports networking. Yeah, this is called a server OS. Okay. Yes. So exactly what is server OS? Let us see here. Yes, multi-user OS, more than one user can share the data. Yes, it could be 2 or 3 or 10 or 100 or thousands of users can share the data here. It supports networking. Yes, this is called a server OS. Exactly what is server OS? Let us see. Server OS. Yes, let us see that. What is exactly server OS? See. Is server. Yes, this is server operating system. Okay. Server OS. Okay. On top of server OS, something is running here. On top of server OS, something is there. Okay, like application. Yes, maybe application or maybe some data. Application or some data. Something is there on server OS. Okay. Yes, server OS server. Yes, it supports networking. Yes, server OS it supports networking. Since supporting networking here, from different locations, users can connect to server here. Suppose, for example, here, yes, user. Yes, user one. Suppose user one or client one. User one. Okay, user one. Yes, next one more user to user. Second user. Okay. Next one more user. 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 Like this multiple users. Okay. Like this multiple users. Different locations. User one, user two. Yes, user three. Yes, user four. Suppose user five. Yes, user six. User seven. Like this user eight. Like this main number of users up to some user n number of users, right? Okay. Yes, here user one. Yes, connect to server OS. So first user request that goes server OS. Server OS supports networking. It supports networking. Since support networking here, users first of all will connect to server ways. After connecting to server ways, they can access app or maybe some data. Okay, right? So first user request to server ways. From that, yes, using this application or data, right? Okay, yes, server ways, since supporting networking here, yes, we can connect to the server ways. So first your request to server ways from that application. Okay, similarly one more user, suppose one more user request. Okay, similarly one more user request, similarly one more user. Yes, all that users here, yes, nothing but clients here, all these clients here, all the clients request here. So all the clients, okay, the clients request here, like this, all users up to number of users. Yes, all these users request simply goes server ways. From the taxing application data, right? Okay, yes, application or data, these are available server ways, right? So these can be shareable. Okay, yes, anything wanted to share it here, that should be deployed in the server ways. Once deployed in the server ways here, through these server ways, we can access all this, all the users can access same data, right? So this data or application sharing by many number of users. Okay, yes, if anything is on the server ways, it's a shareable. If anything is on the server ways, it is shareable. For example here, let us take Facebook here. Facebook, yes, from different locations of the world, we are able to share some data, right? How reason is that is running as server ways. Facebook is running as server ways, so that we can share it. Okay, right? Similarly, yeah, Durga website is running in server ways, so that we can access from anywhere, right? Yes, if anything is running on server ways here, if anything is running on server ways here, yes, many number of users can share data here, right? So anything is on the server. Okay, anything is on the server ways here, it's a shareable, okay, that is called a server ways. Okay, so if you wanted to share something here, that should be deployed in the server here. Once deployed in the server, yes, it's a shareable. Okay, example, Facebook application, it's a shareable, right? From different locations. Durga website running a server, it's shareable, we can access from different location. Yes, next, Flipkart, yes, application shareable, right? So this running as server ways. Since yes, this is running as server ways, is a shareable here. So anything is deployed in server ways, it's a shareable, right? Okay, suppose standalone system, yes, if it is standalone system, that is not shareable because no supporting network here. Standalone ways, single user ways does not support networking. If not supporting networking, we can't access, right? Yes, suppose here networking facilities available from different locations, we can connect to ways, right? Suppose networking facility is not available, how can you connect? We can't connect. Okay, so that single user, this does not support networking. Since not support networking here, that resources cannot be shared here. Only one user can use system resources. This is called as standalone operating system, right? Okay, multi-user ways, more than one user, yeah, that could be 2 or 3 or 10 or 100, thousands of users can share the data. Okay, it supports networking, yes, it is called a server ways, it's a server ways. Okay, so this is about multi-user ways, right? Yes, now let us see all that examples here. Yes, character interface for this single user ways, multi-user ways. Okay, next, graphical interface, here also single user ways and multi-user ways. Let us see one by one here. Character interface and single user ways. For this best example, MS DOS. Okay, yes, let us see about MS DOS. What is exactly MS DOS? About MS DOS, so here, yes, these all are basics. Okay, what is MS DOS? One second. MS DOS, Microsoft Disk Operating System, right? Microsoft Disk Operating System. Okay, MS DOS. Yes, it was developed. It was developed in the year 1945. Yes, MS DOS. MS DOS, it was developed in the year 1945. This is from the Microsoft. Okay, Microsoft Disk Operating System. It was developed in the year 1945. Okay, yes, next. Yes, it is a character user interface. This is MS DOS. So character user interface, character interface. Okay, right? Next, yes, it is a single user OS here. It's a single user OS. It's a single user OS, single user operating system. Okay, yes, it does not support networking here. It does not support, does not support networking here. Yes, you can't do the networking communication here. It does not support networking. It's a single user OS. For character interface and single user OS, it does not support networking, right? So this is first OS in the market here. Okay. Yes, it's a first OS. Yes, MS-DOS is a first OS. It's a first OS in the market. Yes, in software field, it's a first OS here. Okay. MS-DOS is a first OS. It's a character interface. Next, it's a single user operating system. It does not support networking here. Okay. Yes, resources cannot be shared here. Data cannot be shared here. Data cannot be. Yes, cannot be shared. Data cannot be shared using MS-DOS. Using MS-DOS, data cannot be shared. Right. So this is about MS-DOS. Right. Okay. Yes. Next. After DOS. See this character interface. This is a multi-user OS, right? Multi-user OS. Yes, in this UNIX. Let us see about UNIX here. About UNIX OS. UNIX. Okay. So what is UNIX here? Yes, UNIX. Yes, it is a multi-user OS. UNIX is a multi-user OS. UNIX is a multi-user OS. Okay. So this is called server OS. Yes, it is a server operating system. UNIX is a server. It's a server OS. Okay. It's a server OS. Yes, it supports networking. It supports networking here. It supports networking. It supports networking. Okay. Yes, Unix is a multi-user OS. It's a server OS. It supports networking. Okay. Yes, Unix. Yes, it was developed. Okay, it was developed. Yes, it was developed. Developed in the year. Yes, in the year. Yes, in the year 1973. 1973. Unix was developed in the year 1973. Yes, it is a first server OS in the market here. It's a first. Yes, it's a first server OS in the market here. Server. It's a first server OS in the market. Yes, in the software field, correct? It's a first server OS. It is a, yes, it is a multi-user OS. Next, it's a server OS. Yes, it supports networking. It was developed in the year 1973. Yes, it's a first server OS in the software, right? Next, one more thing here. Unix was developed in C language. It was developed in C language. Okay, it was developed in C language. C language. Yes, by the, yes, Dennis Ritchie. Unix was developed by Dennis Ritchie. Okay, and yes, Dennis Ritchie. Yes, next Brian Kernighan, and Ken Thompson at AT&T Bell Labs. At AT&T Bell Labs. Okay. Yes, it was developed in C language. So Unix was developed in C language by the Dennis Ritchie, Brian Kernighan, and Ken Thompson at AT&T Bell Labs. So this is just, yes, history of that Unix base. Initial development. Later undergone so many changes. The changes we'll discuss next here. Yes, Unix is a multi-user OS. It's a server OS here. It supports networking. It was developed in the year 1973. Yes, it's a first server OS in the market here. Okay. Yes, it was developed in C language by the Dennis Ritchie. By the, yes, Dennis Ritchie, Brian Kernighan, and Ken Thompson at AT&T Bell Labs. Right. Okay. Yes. Next here, Unix from the beginning. Yes, from the beginning. Yes, from the beginning, it's an open source operating system here. From the beginning, yes, it is an open source. It is an open source. From the beginning, it's an open source operating system. From the beginning, it's an open source operating system. Yes, what is open source? Yes, anyone? What is open source? What is open source? Any idea?
Source code is available and we can edit it, download it.
Yeah. Okay, fine. Yes, there are two things here. Freeware. There are two things here. Freeware and open source. Open source. Yes, is it both are same?
No,
Freeware
sir.
and open source.
Different.
Yeah, different, right? Okay. Yes. What is freeware? What is open source? Let us see. Freeware. Yes, it can be downloaded. Freeware, it can be downloaded, downloaded, yet free of cost. Okay. Yes. Okay, Ravi, fine. Yeah, right. Ravi, okay. Yeah. Freeware. Yes, it can be downloaded free of cost. Okay, free of cost and can be used here. Free of cost can be used. So can be used. But yes, it cannot be modified. But it cannot be, yes, it cannot be modified. We can't modify it. It cannot be modified. Okay, it cannot be modified here. So freeware, for example, here putty is a tool yet free of cost available. Yes, we are going to work on putty. How to use putty we'll discuss. Okay. Yes, it's admin topic that time we'll discuss. Yes, putty, it's a tool. Yes, this tool is available free of cost. Yes, this tool is available but free of cost, but we cannot modify. Its features cannot be modified. This is called the freeware. Free of cost can be downloaded and you can use here. Yes, without pay, no licensing, it's a free of cost. So this is called a freeware. Yes, we can't modify it. Okay, so we can't modify it. So this is called freeware. Yes, what is open source here? Yes, open source. Open source means, yes, it can be downloaded free of cost, including source code. It can be downloaded at free of cost. At free of cost, including source code. Including source code. Including source code. Okay, including, yes, including source code. Including source code. Okay, yes. After download including source code, next it can be modified. It can be modified. Okay, it can be modified here. Freeware cannot be modified, but open source can be modified. Only freeware which cannot be modified, but open source can be modified. It can be modified and redistributed in the market here. It can be redistributed, redistributed in the market here. In the market with your name here, with your brand name. Okay. Yes, Unix is an open source. Unix is open source. So complete Unix source code means are C programs. Unix was developed in C language. Yes, Unix was developed in C language here. All the C programs, you can download it and we can modify that code here. We can modify that C programs. After modification of the programs, you can rebuild. After rebuilding here, you can release the market with your name here. For example, here DurgaSoft. DurgaSoft, it's a company. DurgaSoft company, they can download Unix source code, complete source code. They can download complete source code and they can modify here. After modification, they can release the market with their name. DurgaSoft Unix base. DurgaSoft. So with their name, DurgaSoft Unix here. So this is called open source. Okay. Yes, since Unix is open source here, many companies taken that source code, modified and released with different names like Linux, Solaris, Linux, Solaris here, Linux, Solaris. Okay, next IBM AX. Okay, next HP Unix. Yes, these are the different yes modified versions of Unix base here. Yes, Linux base, Solaris base here, IBM HPX. Okay, IBM AX and HPX. These are the different different modified versions. So these are called as flavors. These all are called as flavors of Unix base. These are the flavors of Unix base. Flavors or distributions also we can say here. Flavors or distributions, different distributions of Unix base. Flavors or distributions of Unix base. Okay. So here Linux basically from the Unix base. Solaris, IBM and HPX. These all are from the Unix base. Okay. See Linux by the Linus Torvalds. Okay, next Solaris. This is from the Sunsoft. Sunsoft has taken Unix base. They modified, released as Solaris. So this is from the Sunsoft. This is from the Sunsoft. Okay, Sunsoft now it is Oracle Corporation. Yes, this Solaris. This is with Oracle Corporation. Sunsoft taken over by the Oracle Corporation. Okay, next IBM X. This is from the IBM. This is from the IBM. Okay, next HP Unix. Next is HP Unix. This is from the HP company here. Okay, this is from the HP. Okay, so this is from the HP here, right? So these are the flavors of Unix base. So all their modified versions of Unix base. Clear? Okay. So since Unix is open source, many companies taken this. Okay. Yes, many companies taken this source code, modified and released with different names. Okay. Linux. This was done with Linux Star World. Linux Star World. This Linux history later we'll discuss. That history of Linux base later we'll discuss. Solaris from the Sunsoft, IBM X from the IBM here. Yes, next HPX from the HP here. Right? Okay. So this is about Unix here. Right? Okay. Yes, in document it's there clearly. Okay. Yes, in document very clearly explained here. Right? Okay. Yes. So here character interface, single interface, example MS-DOS. Character interface, multi-interface, examples Unix, Linux, Solaris, IBM and HPX here. Next, let us come to GUI base here. GUI. Okay. Yes, next about GUI. GUI. Okay, GUI base. Yes, GUI base. Yes, Windows is the first GUI base in the market here. Yes, Windows is a first GUI base in the market. GUI base in the market here. Okay. Yes, it was developed in the year 1990. First version of Windows is Windows 1.0. First version of Windows is Windows 1.0. Okay, next version is 1991. Yes, it's a Windows 1.1. Okay, next 1992. Yes, it's a first GUI base here. First GUI base in the market here. Yes, Windows 1.2. Next 1993. Yes, Windows 1.3. So all these are called 1.x versions here. 1994. Yes, Windows 1.4. These versions are called as Windows 1.x versions. Yes, Windows 1.x versions. Next in the year 1995. Okay. Yes, 1990. Complete GA, Windows 95 was released. Windows 95 in the year 1995. Next 1998. Yes, Windows 98. Okay, Windows 98. Yeah, these all operating systems are standalone. These all are standalone. Okay. Yes, does not support networking here. These does not support networking. Yes, very old days here. Okay, before 2000 all this happened, right? This does not support networking here. Yes, see here during the period. Yes, during the period 1994 and 95 internet started evolving. Internet started evolving, right? Yes, to support internet, Microsoft, yes, Microsoft added networking technology. Yes, networking technology. Yes, networking technology to Windows. Networking technology to Windows base. Okay, Windows and released. They are released as Windows NT. Yes, Windows NT. It was released in the year 1998. Windows NT. Yes, 1998. Networking technology. NT stands for networking technological. Yes, Windows NT. Windows NT. Yes, is a Windows NT. Yes, it is a first. It is a first GA server in the market. First GA server. Okay, GA server. Yes, Windows NT is a first GA server. After Windows NT here, next Windows. Yes, Windows 2000. Next is Windows NT, Windows 2000. After Windows 2000, next Windows XP. Sorry, yes, Windows NT, Windows 2000. Next Windows 2003. Yes, after this Windows XP, Windows XP. Yes, after XP, next Windows 7. Next Windows 8. Next Windows 10. Windows 10. Okay, so this history here. Yes, Windows NT is a first GA server. Yes, all the servers NT 2000, 2003, XP 7, 8, and 10. These are servers. Okay. Now latest in the market here, Windows 12. Yes, Lite edition. Windows 12 Lite edition. Yeah, this is with Linux kernel. Yes, it will be releasing with Linux kernel. Okay, Microsoft, they have taken Linux kernel, they have purchased Linux kernel and added to Windows 12. Windows 12, this is with Linux kernel here. For the purpose of security, to achieve security, they have purchased Linux kernel and added to Windows base. So Windows 12 with Linux kernel. So Windows 12 Lite edition. Okay, yes, it's not officially released in the market here. Yes, internal release. Yes, Microsoft, they have released internally, but not released officially in the market. Okay. So next OS is Windows 12 Lite edition. This is about history of all these operating systems. Okay. So this is just basics here. So what is system software? What is application software? What is driver here? What is OS? Next, character interface, graph interface, single user and multi-user here. Yes, example, single user, character interface, multi-user, graph interface. Yes, like this, all the examples here. 95, 98, all this here. All this. Okay. Yes, here these things, these all are standalone systems. Does not support networking. These were outdated. No one using. Outdated. Yes, nowadays all the servers, 7 is server, 8 is server, 10 is server, Linux is server, Unix server, all the servers here. So this is just introduction about OS. Right, okay. That is history and different kind of things like this. Next about Linux and Unix. Yes, this topic tomorrow will be starting. Okay, tomorrow I'll start Linux features. What are the features of Linux base? So what are the features of Unix base? Difference between these two, the topics we'll discuss. So tomorrow I'll be entering into the actual topic, Linux topic. Okay. Today all that basics were discussed. All that basics were finished here. Tomorrow I'll be entering into Linux base. Actual topic we'll discuss. Right? Okay. Yeah, RHC also. Okay, that also definitely. Yes, you can 100% you can write RHCA and RHC both. All right. Yes, anything else? Any doubts for today? Okay. Yeah. So let us wind up for today. Right. Okay. Yeah. Thank you guys. See you tomorrow. Yeah.
Thank you, Anna.
Thank you, sir.
Yeah. Thank you. Have a great day. Yes, shell
Thank you.
scripting, including shell scripting. Shell scripting 10 days, 10 classes shell scripting. Admin topics 10 classes. User level commands 10 classes. Shell scripting more than 60 to 70 examples going to cover. Okay, shell scripting more than, yes, 60 to 70 examples. That whatever I worked in real time, yes, same scripts I'll be explaining. Okay, right? Yeah. Thank you. Have a great day.